Section 4.5 is quadratic equations. I can solve quadratic equations by factoring, and I can solve quadratic equations by graphing. Big ideas for this section. The zeros of a quadratic function, y equals ax squared plus bx plus c, can be found by solving the related quadratic equation if we set y equal to 0. Some quadratic equations in standard form can be solved by factoring the quadratic expression and using the zero product property. And the real solutions of a quadratic equation show the zeros of the related quadratic function and the x-intercepts of its graph. Whenever the graph of a function f of x intersects the x-axis, f of x equals 0. These values of x are called a zero of the function. So take note, zero product property on page 226 says if a times b equals 0, then a had to be 0 or b had to be 0, or if they're the same, both. So what this is telling us, guys, is the only way we can multiply to 0 is if one of our factors was 0. So we can set them both equal to 0, and that gives us our solutions. In example 1 here, we're solving quadratic equations by factoring. What are the solutions, or the zeros, of the quadratic equation here? Well, it's already set equal to 0, which is perfect. We need that in order to solve by factoring. Now we're going to factor. So we're going to multiply to 6, add to 5. My options for 6 are 1 and 6, adds to 7, not what we want, and 2 and 3, which adds to 5. That's what we're looking for. So to multiply to x squared is x times x. We added or found the sum, which means my signs are going to be the same. Here, they're both going to be negative. 2 and 3. And again, that's because my outsides and insides I'm going to add up to get to negative 5. And when I take negative 2 times negative 3, I get a positive 6. Now, the only way that we can multiply to 0 is if one of my factors was 0, or my other factor was 0, or both. So x minus 2 could have been 0. This entire thing could have been 0. 0 times x minus 3 would give me 0. Or x minus 3 could have been 0. 0 times x minus 2, 0 times anything is 0. So my only options here when I solve for x that could make this statement true are if x is 2 or if x is 3. And we can substitute those back in to check. I get 4 minus 10 plus 6. Zero equals 0. And I get 9 minus 15 plus 6 equals 0. And that checks as well. Now, feel free to pause here and give this a try if you'd like. Before we can factor it, it has to be set equal to 0. So I'm going to add 12 to both sides. Again, before we can factor, we have to have everything on the same side. All of our terms together on one side equal 0. Now, here, I'm going to try and multiply to 12 and add to 7. My options for 12 are 1 and 12, which add to 13. 2 and 6 add to 8. 3 and 4 add to 7. So those are going to be the ones that I want. They both multiply to 12 and add to 7. To multiply to x squared is x and x. To multiply to positive 12, okay, I found the sum here. My signs are the same. And in order to multiply to a positive 12, my signs have to be the same. The middle tells me what those signs are. Here, they're both negative. So 3 and 4. Now, my zero product property says the only way that I multiply to 0 is if one of my factors was 0. So I can take x minus 3 or x minus 4 equal to 0 and solve. X could have been 3 or x could have been 4. Either one of those give me a true statement. Example 2 here, same idea. I have to get it set equal to 0 first. I'm going to add 2x and subtract 2. Gives me 5x squared plus 32x plus 12 equals 0. Now, I have a number in front of my x squared. I try and factor it out if I can, but 5 doesn't come out of 32 or 12. So instead, I'm going to use the swing method. I'm going to swing that 5 to the back as multiplication, rewrite my expression. Now I'm going to multiply to 60, add to 32. 1 and 60 is 61. 2 and 30 is 32. So that's what I want. Because I added and found the sum, it means my signs are going to be the same. Here we check the middle. They're both going to be positive. So we said 2 and 30. Now, we have to undo our swing here. So I multiplied by 5. Now I'm going to divide by 5. Reduce if we can. If not, we swing that denominator in front of our numerator. Or sorry, in front of our x term as our coefficient. Sorry. Swing the denominator in front of our x as our coefficient. And there's my factored form. Now we can use our zero product property, which says the only way we multiply to 0 is if one of our factors is 0 or our other factor was 0 or both. Solve. And here are our solutions. -2/5 or -6. Now, feel free to pause here and give this a try if you'd like. First thing I'm going to do is get it set equal to 0. So I'm going to add x and subtract a 4. 4x squared minus 13x plus 3 equals 0. I have a number in front of my x squared, so I look at this 4. I can't take it out of 13 or 3 because they're both prime, so instead I'm going to swing it. Again, we always want to check for a greatest common factor. Here, I don't have one other than 1. We're going to multiply to 12, add to 13. Well, my options for 12 are 1 and 12, which adds to 13. That's what I'm looking for here. So again, to multiply to x squared is x and x. Since we added or found the sum, my signs are going to be the same. We check the middle. Here, they're both going to be negative. And I get -1, -12. Don't forget that we have to undo that swing. Since I multiplied by 4, I have to undo it by dividing. Reduce if we can. If not, we swing that denominator to be our coefficient, our number in front of our x, and keep our numerator there. Now, zero product property says the only way that we can multiply to 0 is if one of our factors was 0 or our other factor was 0. Okay, that's the only way we can multiply to 0 is if one of the things we multiplied were 0. So if we set them equal to 0, we can solve to figure out what those values are. Here, 1/4 or 3. And we can plug those both back in to check, and they will work here. In example 3, they want us to solve this quadratic equation by graphing. We're going to do it by factoring because we don't have graphing calculators, but I will show you how it works on Desmos as well so that you can see what happens if you have a graph and what these solutions mean. So the first thing we're going to do here, and I know that we can graph these by hand, but when we graph them by hand, our branches don't always go exactly along the right path. So we'd have to keep trying values until we get them. And it's kind of a guess and check type thing. So instead of doing it that way, we're going to solve by factoring when we can. So here I'm going to get it set equal to 0. Subtract 15 on both sides. I can't take a 2 out of everything, so instead I will swing it as multiplication, rewrite it. Gives me x squared plus 7x minus 30 equals 0. Now, to multiply to x squared is x and x. Here, we are going to multiply to 30 and subtract to 7. My options are 1 and 30, which subtracts to 29, that's not it. 2 and 15, which subtracts to 13. And 3 and 10, which subtracts to 7. Since I subtracted, I found the difference, which means my signs are going to be different. We check the sign in the middle. Here it's positive. That always goes with our bigger numbers. So positive 10 minus 3. Before we can do the zero product property, we have to undo our swing here. So we multiplied by 2. We have to divide by 2. Reduce if you can. If you can't, swing that denominator. So here we get 2x minus 3 times x plus 5 equals 0. Zero product property says the only way we multiply to 0 is if one of our factors is 0 or our other factor was 0. Now we solve by adding or subtracting and then multiplying or dividing, and I get 3 halves or negative 5. We can also solve this by graphing if we type in our equation, into like a graphing calculator, or we graph it by hand. But again, when we graph it by hand, we have to make sure that our branches go exactly where they're supposed to, so a lot of times we'll have to try more points. So we're going to do this one on Desmos. Okay, so here I typed in my function 2x squared plus 7x minus 15, and it gave me this parabola. In order to find my solutions, remember our x-intercepts are the same as our solutions and our zeros of our function. So if I click on my x-intercepts here, it tells me x at negative 5 and x at 1.5 would be my solutions. Those would give me a y value of 0, which is what we have when we set our function equal to 0. So here x equals 1.5 or 3 halves, and x equals negative 5 would be our solutions. And those match the solutions we got when we solved using the zero product property. Now feel free to pause here and give this a try. We're going to multiply to 24 and subtract to 2. Options for 24 are 1 and 24, subtract to 23. 2 and 12, subtract to 10. 3 and 8, subtract to 5. And 4 and 6, subtract to 2. So again, to multiply to x squared is x times x. We subtracted, which means we found the difference. So my signs are going to be different. We check the sign in the middle for the bigger number, so plus 6 minus 4. Zero product property says the only way we multiply to 0 is if one of our factors is 0 or our second factor is 0. So we solve here for x and get negative 6 or 4. And if we solve that by graphing, we sure could graph them by hand, but again, we're going to have to keep trying quite a few values to get where we need to be. Our axis of symmetry is going to be at negative 1, so it's 5 places over on each side, so we'd have to try a lot of different points there to get those solutions. So we can either do it by graphing by hand. If we have a graph, we can pick out our intercepts, or we can try it by factoring, again, if it factors. Quick recap here. The zeros of a quadratic function, y equals ax squared plus bx plus c, can be found by solving the related quadratic function if we set y to 0. Some quadratic equations in standard form can be solved by factoring the quadratic expression and using the zero product property. And the real solutions of a quadratic equation show the zeros of the related quadratic function and the x-intercepts of its graph. And that's all I have for section 4.5.